Alright, Barton. Hopefully you can see everything here. I've got about 30 minutes here to do this before I need to run, so we're going to throw a back end or bottom end together. I've already plastic gauged all the main journals, and I'll send you pictures of those. I had to swap out journal number 1's bearings twice and ended up moving up, I think, 4 color codes to get it into spec, and had to order those, so it's been a couple months now. But all the main journals are now in tolerance, including the special super tight tolerances for 1 and 5 because they're the main load bearing ones. And then all the connecting rod journals, those are all in spec now. 2 and 4 both had to get replaced and moved up 2 color codes each because they were more worn or had more material removed when the machinist reground the connecting rod ends back into circularity than 1 and 3. So, but everything matches. They're all about exactly 1.5 thousandths clearance now. So, pretty happy how they ended up turning out. So, first thing I'm going to do is get a nice heavy load of assembly lube in all of these, so that when we start, if I don't end up getting the electric oil pump system installed, it won't have a dry start. So make sure that it's safe either way. And I like using the Redline Red Gunk, probably just because it's the first stuff I use and I'm just used to it. It doesn't really matter what you use as long as it sticks. It's basically just a gelled oil. Honda recommends 10 weight 40. I've got a little hand squeeze can over here, 1040, I use for all the pre-fit steps and miscellaneous stuff. But for supercritical stuff, I put this on as well, and I know it's going to stick around for several months, like in the case of the head, which has been sitting there waiting for me. And it will hold up through, extended crank interval while you're waiting for the oil pump to pressurize and other stuff. It's basically just gelled oil that's got a bunch of extra moly in it, so that it will hold up to higher pressures than normal oil would. And because it doesn't have suspended particles in it, I don't believe, it will not clog up your oil filter or your passages. So the whole idea is that it dissolves and disappears when you do your first oil change. So I'm just coating all these guys up now. And I also went through, you can see that pretty well. Also went through and blew off all the mating surfaces pretty thoroughly with compressed air. Just because if there's anything caught in there, it ain't ever coming out, because once we tighten that thing down, those surfaces are sealed. So, those are all the main journals and all of the connecting rod ends. Now we're going to take our crank, and I'm going to do something a little like that. It's not the official Honda procedure, but I don't think it causes any trouble. Okay, set that in place. And I'm going to go ahead and put in the thrust washers now, just so I don't accidentally forget about it. You're supposed to tighten the caps next, but I don't trust myself. Yeah. So grooved faces go out on the thrust bearings. And I've actually never installed these. I wanted to remove them, so hopefully these things go right in. So we got a smooth face on one side and two big oil passages on the other side. Oil passages go against the crank on the outside. So these should just rotate right into place. First side, obviously pretty easy. I'm going to load that. Should be able to slide the other one right in behind it. Or on the opposite side. Groove out. It goes right in there. Yep, easy peasy. Okay, so those are the thrust bearings. And when we're done, I'll probably get my dial indicator out and check those, but the originals with 250,000 miles on them were still in spec for end play. And that's play of the crankshaft back and forth along the axis of the engine. So I'm not expecting to have any problem with the replacement ones. Okay, I'm going to go ahead and coat up all these journals because we're going to put in the caps next for the connecting rods. They need to go on first because the saddle that covers all the main bearing journals is going to cover everything, and you'll be able to get access to these guys. So you kind of have to put them in first. And I might as well just go ahead and coat these now that I've got it out, and we don't have any worries about forgetting things. As far as I know, there's no way to put too much of this stuff on, because all it's going to squeeze out and it will bleed out any excess through the oil passages. So it should be in good shape. And I think I've told you I'm planning to put an electric oil pump on this and have it set up before I ever turn it over, so this engine will never ever get a cold start in its life. So ideally what will happen is I'll let that run for a few seconds. It'll flush all the assembly lube out before it ever gets started for the first time. But we'll see. Okay, rod ends. They're all matched and they all have etched codes on them. Pretty sure you can't see that here, but you know, they only go on one way, and the codes make sure you have the right end going on with the right mating connecting rod. And I'm going to go ahead and hit these with the air gun to make sure any residual fibers are evicted. So it's going to make a hell of a lot of noise. Sorry. Number one. Number two. Number three. marginally interesting little factoid. From the factory, Honda stamps little number codes on the seams of all the caps and rods. And they're in the range of 1 through 4, but they are not the cylinder numbers. In this engine, I think they're like 2, 3, 3, 2. Those are the size codes, not the cylinder number. So if you're doing this, don't get thrown off by those. My machinist is really cool and actually added secondary stamps on both halves of the connecting rod and cap with the cylinder number on it so I can keep them straight. So there are 3 numbers on each of these, 1 across the seam for the dimension, and then 1 on each side for the cylinder number. Okay, and then I'm going to put on just a bunch of 1040 on these seats so that when I torque them down, I get nice full torque on them without binding. Now this is one of those things that if you're doing a high performance build, you do not do this way. The proper way to do a connecting rod bolts is by measuring the stretch on the bolts, not by torque. I don't think Honda even had a spec for this stretch in their bolts. So we're just going to do it by torque, which is what Honda specifies. I think there's a general guideline that you can follow. I've got a copy of whose book is it? Rick Fogelin's Engine Blueprinting handbook, which I think is one of the better ones out there, and it has all this information in it and all the steps you should follow and guidelines to use. He has information there about what sort of bolt stretch you should aim for on different parts. So you can follow that, but this is a 100 horsepower low torque engine. I'm just going to follow the factory procedure. So I'm just putting all the nuts on here loose by hand first. None of these caps are actually bottomed out right now. They're very tight fit on the studs, and I'm just going to use the nuts to pull them into place. And you'll see I have to alternate back and forth because they bind very easily. So I can usually put about 2 turns on each side before it binds up and I have to switch sides. So we're just going to lock all these on before we do the actual torquing step. So we'll get all these guys on. Probably, you may actually be able to see in this camera view. You may notice in the inside tops of the pistons there's a little shiny streak right in the middle. My machinist actually machined out a little bit of the heads of all the pistons so they match the original weight of the stock 75mm bore pistons. These are 75.5s, so they're heavier, but he milled material out to match so that we didn't have to rebalance the crank. So, kind of a nice little touch, and it should make it run indistinguishably from the original. Yeah, you could definitely see that. You can see it on the previous screen, right there. That shiny surface right there. That's the section he milled out to make the weight balance. From factory, they were all within 1/10 of a gram matched, so pretty good QC from folks over at Honda. Okay, so those are all now set in place by hand, and we're going to torque them to 23 foot-pounds. Yeah, 23 foot-pounds. And connecting rods, it's not a two-stage torque per Honda, so we'll probably just go more or less straight there. And let me do it from, I guess, from this angle. I'm going to do it roughly to 15. And then I'll do final to 23. Okay. Okay, all 8 of them into 23 foot-pounds, about 35 newton meters, 32, 35 newton meters. Okay, so those are all the connecting rod caps. 2 thrust washers are in place. It's time to put in the saddle. I've already checked the clearances on all those. I already said that. These are going to be a 2-stage torque, so we're going to go 18 and then to 33. The big VTEC engine has them at 38, but this is a normal one, so it uses a 33 foot-pound. And the tightening sequence is important, but I've already taken the liberty of writing that on the saddle, so you see that in just a second. I'm going to go ahead and blow these surfaces off again, make sure they're nice and clean, and then we'll go to town. I also yesterday went through and cleared off all of the gunk from the threads on the bolts, so any residual aluminum shavings or particles or anything else, so they're nice and clean. And I did that before the final plastic gauge check I squeezed in yesterday afternoon sometime. And they came out clean as well, so I'm pretty confident there's nothing down inside the block on the threads. I did not chase these threads, I don't think, but this went through the pressure washer bath at the machinist, and they're all nice and shiny down there. I can see all the way to the bottom, and there's nothing in these things, so they're nice and clean. I went through and blew all this off. I'm just doing one last quick check and moving anything that looks not liquid. Not too worried about the little lube there, that'll just get squeezed right out. Okay, so here's my saddle. The main oil galley feed goes through a dowel pin and lines up with that hole right there. I've already got lube in there. Everything's clean and dry. So that's just going to set in place there. And we'll get that thing set. So there's dowel pins in every single one of these holes except for that one, and that one has a big one here. So it takes a lot of work to both get this thing in and to take it out again. So plastic gauging this is a pain in the ass because you've got to break this apart every time to read your plastic gauge. So one round of measurements usually takes me about half an hour. Alright, I'm going to stop there and then we're going to work all these guys in with their bolts. This side's running a little bit high and I don't want to do any damage here. So, same thing again. I'm going to put in a nice generous serving of 1040. On all these torque surfaces. And you can see I've written in the torque sequence. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to do this in roughly 4 steps or so. First 2 just to get everything down and kind of in position. So close up all the loose gaps. And that one I'm not necessarily going to do in the full sequence because I want to pull it down parallel. There we go. Okay, so we're down to about a millimeter gap, about ½ millimeter on this side. These are the original bolts. It's not common that I've read about replacing your saddle bolts, and you've got 10 of them, so there's actually quite a few of them sharing the load. The head bolts, I am replacing those, and that's more because this engine has a known problem with the head gaskets, and part of the design fix Honda issued, which ironically was not a recall, it was only an available special service part with the recommendation that if the head gasket blew, you assume the engine had been affected and then it got the replacement parts. And part of that kit was a new design to head bolts that presumably hold a higher tension than the stock design. So I'm just tweaking that side in right there, and now everything is down. Just do one last pass in the torque order on all of these bolts so that we now have all the surfaces closed up and we're ready to start our actual torquing sequence. Like I said, we're going to go to 18 pounds first, And then we're going to go all the way to 33, and that's going to be the finish. So, number 1 to 18, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's do one last double check with the spec. Second step, 33 pound-feet, 45 newton meters for all blocks except for the D16Z6. That's us. So, we're going to 33. 33. 33. 33. 33. 33. 33. 33. 33. And 33. And there's your bottom end. That's pretty much all there is to it. I need to prep the seals, the new seal for the flywheel end. That gets bolted on to the engine face, and there's some gasketing that has to go in there. I need to install the oil pump and its seal. That's going to go on here with some more gasketing, and then put in the oil pickup that's going to bolt in there. But yeah, there's the bottom end.